Hello, today we're going to read Chapter 16, The Wizard of Electricity. Sometimes disadvantages can be turned into advantages. Thomas Alva Edison had two big disadvantages. He had almost no schooling, and an accident made him deaf about the time of his 12th birthday. Edison spent only a few months in school. His school teacher mother taught him some at home, but mostly he went to the library, got books, and taught himself. That ability to do things for himself helped him to become the most successful inventor the world has ever known. Being deaf, or almost deaf, may have helped too. It allowed him to concentrate without being distracted by conversation or sounds. Thomas Edison was a lonely boy, but he had every favorite science book in a chemistry set, and he tried experiments over and over again. In addition, he was a tinkerer. He liked to see how things worked. He would take something apart and then put it back together. Usually, when he put it back together, he made it work better. He was fascinated by the new telegraph machines. When he was 11, he made one of his own. He intended to send messages back and forth between his house and another, but he needed to find a source of power, and he needed money for equipment and experiments. His parents had none to give him. So Edison went to work on a train selling candy and newspapers. Since he had extra time on the long ride, the train people let him put his chemistry set in the baggage car. That baggage car was his first laboratory. One summer day, Thomas Edison was standing on the train platform while his train took on water and fuel. He noticed a small child toddling across the tracks. Then he saw a freight train coming down those tracks. Edison jumped down from the platform, dashed in front of the train, and rescued the child. That action changed his life. The baby's father was a telegraph operator. He wanted to reward the brave 15-year-old candy seller. What could he do for him? Teach me to be a telegraph operator, said Edison. He soon learned Morse code and to send it rapidly. It was a useful skill. A good telegraph operator could work almost anywhere in the country. Edison got a job in Michigan. Then he went to Boston and then to New York, but he was soon bored just sending messages. His tinkering mind was at work. He thought he could improve the telegraph, so he invented a writing telegraph, a machine that wrote words, not just dots and dashes. He had other ideas too. Western Union, the company that owned the telegraph system, asked him to asked him to sell his ideas. Edison figured they were worth about 3,000, but he told Western Union to set a price. When they offered him $30,000, he was astounded. From that time on, Edison was a full-time inventor. In 1876, that centennial year, he set up a laboratory in Menlo Park, New Jersey, with a team of gifted assistants. It was the world's first modern research laboratory. He called it an invention factory. For the next 5 years, he patented a new invention almost every month. He invented a motion picture camera, a projector. He built the first motion picture studio, which was the beginning of the modern film industry. He invented a mimeograph, a type of copying machine, the storage battery, an electric locomotive, waxed paper, and composition brick. He discovered the movement of electrons in a vacuum, and that led others to radio and modern electronics. Edison patented more than 1,000 inventions before he died. One day Edison left a drawing on the bench of one of his assistants. At the bottom of the paper was a note. "Make this," it said. "What will it do?" asked the assistant. "It will talk back," said Edison. It did. The phonograph came from that drawing, and that led to the tape and CD players that you listen to. Edison's first phonograph machine had to be cranked by hand, and the first record was a song that Edison sang himself. It was Mary Had a Little Lamb. The most famous of all Edison's inventions was the electric light bulb. He didn't actually invent electric light. Others had been working on the problem. In 1859, Moses Farmer in Salem, Massachusetts, had made two lamps with platinum filaments. Platinum is more expensive than gold. There was no way most people could afford light from that kind of bulb. Edison announced he would take 6 weeks to develop a light bulb that could be made inexpensively. Well, he was wrong. It took him a little more than a year. He knew that oxygen helped things burn, and he wanted his light to glow, not burn. The air would have to be pumped out of the bulb, and the glass should be clear so that the light would shine through. Edison hired a skilled glass blower to perfect a pear-shaped vacuum bulb. Now he had to find a way for a filament, some kind of fiber or something to carry electricity, give off light, and last. He tried metals, papers, cork, and lemon peels. He plucked a hair from his friend's beard. He tested 6,000 vegetable fibers. Most of them fizzled or collapsed. Finally, he used a simple cotton thread made stiff with carbon. On October 21st, 1879, Edison took some of that thread, put it in a glass bulb, pumped out the air, and turned on the current. The bulb glowed like the setting sun in a dusk of early autumn, wrote one of his assistants. Edison and his staff sat down to wait. How long would the bulb glow? They waited and waited. Night came. In the morning, the lamp was still glowing. The next night came. The bulb was burning and brightly as ever. That light shone for about 45 hours. Edison had found what he sought. Improving the light bulb would be easy. Edison was a practical genius. He had devised a lamp that would not only provide light, but could be used everywhere. We will make the light bulb so cheap, he said. Only the rich will be able to burn candles. But light bulbs are no good without sockets to plug them into, and light switches, and safety devices, and meters, and electric wiring, and dynamos to provide power. Edison invented some of those things and improved others. He turned the switch on the modern world of electricity. Edison wanted to electrify New York City. That meant laying wires underground. It meant building huge generators. It was an untried idea. It would be very expensive. Edison needed help. He needed money, a lot of money. Grosvenor Porter Lowry, a Wall Street lawyer who was fascinated by science, convinced bankers and wealthy individuals to finance Edison's schemes. Lowry also helped to convince politicians to arrange for city rights. After all, Edison needed permission to dig up city streets and lay wires in order to take electricity from house to house. On September 4th, 1882, Thomas Edison stood in the offices of J.P. Morgan's New York banking firm. He pulled a switch. A few blocks away, 6 giant dynamos began to hum. Minutes later, electric lights lit the banker's offices in other parts of New York City. Edison's inventive mind was soon hard at work on other projects. Genius, said Thomas Alva Edison, is 99% perspiration and 1% inspiration. Edison must have done a lot of perspiring. He slept only a few hours a day and expected those in his laboratory to keep up with him. Edison was our most gifted and famous inventor, but at the end of the 19th century, America seemed a land of inventors. In 1850, The U.S. Patent Office gave 173 inventions. Between 1860 and 1890, the number was 440,400. Telsa in the Battle of the Currents. In 1884, the brilliant Serbian-American inventor Nikola Tesla came to the United States to work in Thomas Edison's New Jersey lab. It wasn't a happy collaboration. The colleagues soon became competitors. Tesla went head to head with Edison in what became known as the Battle of Currents. When Edison set up his power distribution system to deliver electricity to part of New York City, he used direct current, DC. Direct current works in batteries, but it's not easily transmitted over long distances. Tesla developed a system of motors and generators to transmit electricity in the form of alternating current, AC, which can travel over wires for hundreds of miles. A wealthy industrialist named George Westinghouse bought Tesla's patents a and proceeded to develop an AC power system using generators devised by Tesla. AC won the battle of currents. Today, when factory motors turn or when you switch on a light, it's AC work. Tesla liked to give public lectures about the wonders of electricity. He would wow audiences by putting on dazzling electrical displays with sparks flying from his fingertips. When he became famous as a showman, he was in fact a serious inventor whose work helped make possible the readily available electric power we take for granted.